Hi, my name is Lim Chushen, and this is my project titled Object Recognition Smart Glove, a glove that provides strength to those who needs it. Let me start off this presentation by giving you a scenario. Meet Alex. Alex is an 87-year-old man diagnosed with dementia leading to Parkinson's disease. For those of you who don't know, Parkinson's disease is a terrible progressive brain disorder that affects the nerve cells in the brain responsible for body movements, and there is currently no cure, so only preventative and rehabilitative measures could be taken. People affected by this disease would usually have difficulty in body movement and body coordination, and that was what happened to Alex. He had an extensive loss of hand function with a limited range of motion and reduced strength in his hands. When Alex's family found out that he had this disease, his family immediately researched on what could be done to delay the onset of this disease. They found out through their doctors that Alex should immediately start with rehabilitation exercise training through physiotherapy. So that's what Alex did. He started daily sessions with his physiotherapist in hopes that he can form a muscle memory and gain strength for his hands. So traditionally, how a physiotherapist would gauge hand function assessments is through a mechanical or an electrical goniometer placed across the joint of interest to measure joint movements. These devices are highly intricate and requires extensive knowledge of joint movements to gauge the progress of the patient. Therefore, only specialists such as physiotherapists has the knowledge to gauge the performance of an individual in a quantitative manner. This is a problem for Alex, as this means that he has to meet with his physiotherapist at least a few times a week or he wouldn't be able to see his progress. Not only that, moving here and there causes a lot of strain on his already weak body. So this means that he has to rely on his friends and family to spend the extra time to care for his needs, such as transportation to and from the physiotherapy center. Alex was my grandfather. Unfortunately, he passed away a few years ago due to complications with this dreadful disease. However, he has inspired me to take on this project, which I believe would be a huge help for those in a similar situation. I have created a smart glove that can recognize objects using a supervised machine learning algorithm. This glove is able to track the degree of joint movements, and it is able to predict the object that the user is holding with the current self-learning network. Also, with the data produced by this glove and a slight change in programming, this glove can also track the grip strength, joint mobility, and pinch strength of the user. A machine learning algorithm can then be applied to gauge the improvements of the user over time. So, why do I believe that this product will be better over the current market solutions? The first is, as I've mentioned above, this product ultimately does not require a specialist to gauge your performance. This means a reduction in visits to the physiotherapy center, as the rehabilitation training can be done at home with instant feedback from the glove. In any case, if a specialist's advice is truly needed, the data from this glove can also be used by the physiotherapist to gauge the long-term performance of its users. Another benefit is the versatility of this product. The example that I've given above is just one of the many applications that this product can apply to. Another use case would be that this glove can be used in the virtual reality or augmented reality landscape. As this glove can provide accurate finger movement data to a computer, there will be no need for bulky and handheld controllers to control elements in the virtual world. The machine learning model of this project allows for a wide range of applications due to its self-learning nature. Finally, and arguably the most important aspect of this project, is the cost. As you may or may not know, consumer-grade equipment, especially for rehabilitation purposes, can usually cost very high due to the lack of competition and the monopoly around the industry. Case in point, the picture on the left is the current market solution for a smart rehabilitation glove. The one on the right is the cost of the professional package of this glove, which allows practitioners to create patient profiles. The working principle of the glove essentially is similar to the prototype that I've developed. With this current solution, it is no wonder that the average consumer would much rather spend the time to visit rehabilitation centers to use their equipment rather than spending the thousands of dollars to purchase one for personal use. However, my solution was completed with the budget of a full-time university student with no grants or sponsorship from external parties. My proposed solution costs below 300 ringgit, and if this product is brought to the market, the scale of manufacturing can further bring down the unit cost. Ultimately, this would allow more users to purchase and use this product at the comfort of their own homes. So now I will show a really quick demo video on the real-time prediction aspect of this project. This video demonstrates the different objects that this glove can recognize with an SVM-based machine learning algorithm. The confusion matrix shows that this algorithm can assist the glove in recognizing objects with an accuracy of around 91.8%. The high accuracy aspect of this project shows great promise in the application of rehabilitation, as it means that the data can be used to track improvements of the user over time. For example, the data collected can show an improvement of the user's hand function as well as the highest improvement of grip strength of each finger. In addition, this glove can also provide an educated guess on which exercise regimen is the most effective for any particular user. In closing, neurological diseases that affects the motor skills such as stroke or Parkinson's disease affects more than 2 million people annually in the United States alone. I am confident that the impact that this solution may bring to the world of rehabilitation will be one that is both affordable and sustainable. Thank you.